showing images kind of mutual authentication. I'm talking about fundamental, infrastructure level mutual authentication. Something closer to IPv6. IPv6 is doing a good job on that. They are talking about TCP IP level mutual authentication. So I'm talking about infrastructure here. So what did we do? This is the technology that I want to present here. It's new, and it will take a little bit of your time to understand the various parts to this technology. So we said, throw the browser, use a banking browser. So that's your secure browser. It doesn't have anything else but just what the bank needs. It just connects only to the bank, nowhere else. 2, it runs in a secure desktop. So it blindfolds all the Trojans. It blindfolds all the keyloggers. So no matter what has gone in his machine, the customer is safe from this. Okay. Next, it runs on a mutually authenticated channel. That's what we call as the Rel-ID mutually authenticated channel. And somebody in the afternoon made a comment that the entire cryptographic world, was because of RSA. Yes, RSA did that, but there was another stream of scientists and mathematicians who worked, and those were Diffie and Hellman. Okay, so there is a DH stream of cryptography which happened, which nobody talks about. It went in a different direction. It works on something called as discrete log. The reason I have to highlight that is that was the direction that went into mutual authentication at protocol level. Now SSL, which was launched in 91, did come out with a two-way SSL model, but it was not accepted by the market for various reasons, and I'm sure there is a big movement in ensuring that every customer has it. But yes, it's in the right direction. I'm saying two-way SSL is the way to go. But two-way SSL is expensive. Mathematically, it's very expensive. But DH had come out with a solution which was not that expensive. So we looked at DH and said, let's see what we can do with DH. SPECE is in that direction. I know I'm sounding a little bit cryptic here, but it's important to highlight efforts of people, who have really worked in this area. So the Rel-ID mutual authentication protocol works by ensuring that the bank's browser connects only to the bank's server, and the bank's server only connects to the bank's browser. So you are eliminating the man-in-the-middle attack at protocol layer. 2FA and all that stuff. It's like Taviz. I still remember one of a very senior CISO when I had a conversation with him. He had a very interesting way of putting it. 2FA is all Taviz. You just carry for the belief that it is doing something good to you, but may not be really solving the real problem. FFIC came out with this concept of 2FA 7 years ago in US. Everybody picked on it. 2FA. Let's give the customer one more authentication. He already has login password. Now you are saying he should carry OTP with him. What's the use? You may give him 10 more passwords, dynamic passwords, but at the end of the day, he doesn't know where he's entering all those credentials. He can't authenticate that website. So what I'm saying is 2FA is possible. So we also have a Rel-ID soft card which gives you a 2FA. But 2FA per se is not a solution to the problem at hand. What we are saying is once you have a mutually authenticated channel, you pipe the SSL through it. SSL is a good encryption technology. It ensures that it has a secure pipe. But SSL cannot solve authentication problem at the two endpoints as of now, the way it is implemented right now. So when you're looking at a dynamic private network, I use this word dynamic private network. So what we are talking about here, we are saying that on top of the existing infrastructure, it lays over a Rel-ID enabled dynamic private network, a banking network, so to speak, like a VPN. But I won't go to the extent of calling it a VPN because it's not a VPN. But it's a banking network. It's not the public network that you're dealing with, but it sits on top of the public network. So how does it work? You launch the browser, you enter your user ID and PIN, and you authenticate yourself to the banking browser. This is a banking browser. Nothing else is running on it. We control everything that runs in it. It runs in a secure desktop. We know what all things are running in that secure desktop, all the processes, so we control all that. So now the bank is in control of the customer's machine. It has transformed the customer's machine from an insecure device to a secure device. It has suddenly become like an ATM for the bank. And this is running over a virtual private-ish network for the banks, on which the bank has total control now. So when you basically say login, at that point it connects to the bank server and pulls out the HTML data. We do not touch the banking's application layer. There is no integration required.